Hey everyone, Stelvio here. Welcome back to the channel where we break down data architecture and everything in between. If you are into database and tech, make sure to hit that subscribe button here below, like this video, and share with your datamates. Today we are diving into the world of databases, but not just any databases. Look at that. There are so many types, relational, graph, time series, NoSQL, vector, blockchain, and more. But what do they all mean? And more importantly, when should you use one over another? Stick around and we unpack all the different kind of databases, explore real-world use cases, and help you to choose the right tool for your data-driven solution. Let's go. All right, let's now explore the network databases, a type of database that uses flexible graph-like structure to store data. If you're looking to understand complex relationships between entities, this database is for you. So let's dive in. Unlike traditional databases, which often rely on rigid hierarchical structure or tables, as we have seen, network databases use a more flexible graph structure. This allows data to connect in multiple ways, offering more complex and dynamic relationships between entities. Think of it as a web of connections. These relationships can form complex structure, allowing for multiple interconnected paths between different pieces of data. This flexibility makes network databases ideal for situations where data doesn't fit into a simple hierarchy. Some key use cases include telecommunication systems, where multiple nodes like users networks and a call are all interconnected, transportation systems, where routes, stations, and connections needs to be modeled dynamically, and inventory management, where products, suppliers, and warehouses are linked in multiple ways. One of the most well-known example of network database is the integrated data stores, which is one of the earliest commercial network databases and was designed to store and manage complex data for large-scale applications like telecommunication networks. A famous real-world application of network database is in the telecommunication industry. For example, network databases are used to model and manage the relationships between different elements in a telecommunication network, such as user, device, switch, and communication links. So to summarize, network databases use a flexible graph structure to model and manage complex relationships between data, making them ideal for application in telecommunication industry, transportation systems, inventory management. The integrated data store is a great example, as there are many examples, like for instance, particularly in telecommunication. But at this point in time, you might wonder, what is the difference between graph, network, and hierarchical databases? So you can find the key differences in this table. But to summarize, hierarchical databases are best for situations where data naturally fits into a strict parent-child relationship. Network databases provide more flexibility than hierarchical ones and support many-to-many relationships, but are still more structured. And graph databases are the most flexible, handling complex relationships with deep connections and rich metadata, making them ideal for applications like social networks, fraud detection, and real-time recommendation. Each type of database is suited to different kind of application depending on the nature and complexity of the data relationships involved. And last but not least, the blockchain database. This is a revolutionary technology that is transforming industry from cryptocurrency to supply chain tracking. So let's explore what blockchain databases are, how they work, and some real-world application. Unlike traditional databases, the blockchain databases use a distributed ledger. This means data is stored in a series of blocks each linked to the previous one, forming a chain. The beauty of the blockchain is that once the data is written in the to the ledger, it's immutable, so meaning it can be changed, it cannot be changed. This makes blockchain databases very secure and transparent. Each block in a blockchain contains a list of transactions, and once a block is added to the chain and it is verified by multiple participants across a distributed network, this ensures that the data is accurable and trustworthy, which is why blockchain is so popular for applications requiring transparency, security, and decentralization. Blockchain databases are commonly used for cryptocurrencies today, where they serve as underlying technology for digital currencies like Bitcoin and Ethereum. But blockchain is not just for crypto. It's also used for smart contracts, for instance, which are self-executing contracts where the terms and are directly written into code, and for supply chain tracking, where blockchain provides transparency and traceability for goods moving through the supply chain. Some well-known blockchain databases include BigchainDB and Hyperledger Fabric. These databases bring the power of blockchain to enterprise applications, allowing business to manage decentralized data and transactions securely. One of the most famous applications of a blockchain database is Bitcoin. Bitcoin relies on a blockchain database to securely store every transaction ever made. When you send or receive Bitcoin, that transaction is recorded in a block and added to the blockchain. This distributed ledger is decentralized, meaning no single entity control it, making Bitcoin transactions secure, transparent, and immutable. So to summarize, blockchain database use a distributed and immutable ledger to securely store data, making them ideal for applications like cryptocurrencies, smart contracts, and supply chain tracking. BigchainDB and Hyperledger Fabric are examples of blockchain databases in action, and Bitcoin is a famous real-world application that relies on blockchain technology for secure transactions. And that's wrap on today. Dive into databases. I hope you find this breakdown helpful. If you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the notification bell. Also, let me know in the comment section down below what's your favorite database. Thanks for watching, and I'll see you in the next one. Stay curious, keep learning.